Assalamualaikum and hi everyone. I'm Tasiran Surini Abdul Rahman. This video is recorded for BEJ10102 Computer Programming student. In this video, I will be explaining about Chapter 4, which is on functions, and the slide has been prepared by Madam Zarina Tukiran. These are the objective of Chapter 4. The first objective is to create function, call or invoke function, and pass parameters or arguments to a function. The second objective is to understand the differences between pass by value and pass by address or by reference. The third objective is to use function prototype to declare function headers, and the last objective is on how to determine the scope of local and global variables. These are the outlines of my explanation. The first one is about the introduction of function. The second one is the benefit of function programming or modular programming. The third one is about categories of function, where in function we have standard library function and user-defined function. The fourth point is about function elements, where in function we have three elements, which are function definition, function prototype, and function calls. And the last point is about scopes of variable. In the previous chapters, all the program that have been developed consists of only one main function, where all the instructions or coding are put or packed into main function, into the main function. This technique is actually good if a program is a small program or is a short program, but for a larger program or a longer program, it is difficult to handle the program if the program or if all the instruction are packed into one main function. So in computer programming, modular design or modular programming is introduced, whereby the instruction is organized or divide into several functions, where these additional functions can be called within main function, meaning that one main function is divided into several additional functions, and the additional function can be called within the main function. So in computer programming, we have basically we have three methods of programming. The first one is where all programming instructions are put in one main function. The second method is function or modular programming, where we create and call the additional function from the same main file. Right, so the method 3 is we create the functions in different files. We create the additional function, in different files, and we call that additional functions from the main file. So these are the benefit of modular programming, okay, where by using my modular programming or function programming, it is easy to understand the program, because for one function, usually we create that particular function to execute a specific function or a specific task. So it is easier to the user to understand the program. Okay, the second benefit is reusable code, whereby we can reuse the instruction inside additional function by only calling them. Okay, the third benefit is elimination of redundancy. By using modular programming or by using additional function, we can help to avoid the repetition of writing the same instruction. The fourth benefit is efficiency of maintenance. As I previously mentioned, it is it is easier to handle the programming with several functions that execute a specific task, so that it is when we have a problem, then we just go or focus to that particular function. Okay, so it is easier to handle and easy to maintain the program. So to explain these three methods, I will give you one example. Okay, I go to method 1, where all programming instructions are put in one main function. So for this method, this is the structure chart of the program, where the program contains one main function only. Okay, this is method 1. So this is the structure chart, where the structure chart consists of only one main function. Okay, so this is the example or the problem statement. Create a program to calculate and display the area of cylinder, and this is the the formula to calculate the area of cylinder. Okay, so this is the example of pseudocode for example 1, where I name as example 1A for method 1. Okay, we begin with the word begin, and then we prompt user to key in the value of height and get the value of height. The second step is we prompt user to key in the value of radius and get the value of radius, and then the program will calculate the area of cylinder based on the height and radius that have been keyed in by users, and then the last one, the program will display the value of cylinder and n. Okay, so this is the programming. Okay, maybe I can put, or I can copy, I copy this program into online compiler. Okay, so this is the program. Basically, this program is about to calculate the area of cylinder, whereby if we can see roughly, the program consists of three parts. The first one is we ask user to key in the value of height and radius, and then based on these values, the program calculates the area of cylinder, where the formula is pi multiplied with height multiplied with radius squared. So here we declared or we assign the value of 3.142 as the value of pi. Okay, so and we also declared, since this program involved with 4 variables, which are h to represent the height, r to represent the radius, pi is pi and area of cylinder. All the variables here are declared as double data type. Okay, so this is the first part, as I mentioned before. The second part is to calculate the area of cylinder, and the last part is to display the value of cylinder that that has been calculated by the computer. Okay, so these three parts actually can be divided into several functions. Okay, maybe we can let there are several ways on how to create the functions. It depends on the creativity of a programmer. Okay, for example, in this example 1A, in this example 1, I will divide the program into 3 parts. The first one is the main function. The second one is to calculate the area of cylinder, and the third one is to display the area of. But before we can develop the program, of course we need to come out with the pseudocode first. We have to draft our program first. Okay, so this is the pseudocode of example for method B. For method 2, the second method, which is we are going to create modular programming. Okay, so first we prompt the user to key in the value of height and get the value of height, and then the value of radius, and then we call the user defined function, where I name the additional function as calculate and display. So at the third point here, I call the user-defined function from the main file and pass the value of radius and height to the calculate function. So in the calculate function, this is how we can put the pseudocode. We can create the pseudocode where we put begin and end in the user-defined function here. Okay, so calculate is the user-defined function. User-defined function means the function that has been created by the user. Okay, that one is user-defined function. Okay, so user-defined function calculate. In this calculate function, we calculate the area of cylinder by using this formula. Okay, and then we return the value of area of cylinder to the main function back. Okay, we return back, or we return the value of area of cylinder to the main function, and then we go to the next step where we call the user-defined function display. So display is another user-defined function that created by we as a programmer, yes. And then we pass the value of cylinder of area, the cylinder area, and in the display function, we display the value of cylinder area, and then we return back, or we return the process, we return the program to the main function. Okay, and then we end our program. Okay, so in structure chart, we can draw like this. Okay, for structure chart, it contains of one main function and then two user-defined function. Okay, we name it as calculate and display. So main function will pass the value of height and radius to the calculate function, and then in calculate function we calculate the area of cylinder, and then we return the value of area of cylinder to the main function, and then main function will pass the value of cylinder area to the display function. In display function, we will display the value of cylinder area that has been calculated in calculate function. Okay, and then we return back, we return to the main function. But since this display function is only display task, a task to display the value, so we return no value to the main function. We just return the process to the main function, so that main function can do or can execute the rest of instruction. Okay, so this is the program for example 1B. Okay, 1B, which is by using method 2. Okay, so how to create this program? Let me explain through this online compiler. Okay, so as I mentioned before this, the example 1, the program of example 1 consists of 3 parts. Roughly we can see that this program consists of 3 parts, and we plan to divide the program into 3 parts. The first one is main function, the second one is to calculate the area of cylinder, and the third one is to display the value of area of cylinder. So maybe we can put this part, we can move this part out of main function. Okay, we move the calculate part and the display part to from the main function. Okay, alright, so we now are going to create the additional function, which is calculate function. So in order to create the new additional function, we need to name the function. Okay, this part is actually known as function definition. So if you can see from the slide in page 42, this is the general syntax to create the new additional function. Okay, this is we call it as function definition. Okay, so at the first function definition, or the first elements in function definition is data return type. Okay, what is the return type data, or return data type to the main function? Okay, this is the function name. Okay, function name is very important because it will the program or the computer will refer to this function name if there is a calling a function call. Okay, and then this is the parameter where we put in where we put all the parameters in the bracket, and this is the open bracket and close bracket, and this is the function body where we put the instruction here. Okay, so we go back to the okay, maybe I can give you one example here. Okay, this one is double calculate double H double R. Okay, this is example 1. Okay, double is the return type, and then calculate is the function name, and then this one we call it as formal parameters, okay, or arguments. This one is height and this one is radius. So maybe we can copy the function definition here and we can paste to our newly additional function here. Okay, we just put here, we name our newly created calculate function as a calculate. We name the function as calculate. Okay, and then we put the open and close bracket, curly bracket here. Okay, so this is function definition. Okay, definition. Okay, so since the pi is used in area cylinder function, we no need to put or we can remove the declaration of pi in the main function because we are not using this pi in main function anymore, so we will use it in calculate function. So we put it here, pi is equal to 3.142, and then this is the data type of height and this is the data type of radius. Okay, we need to declare here. Okay, and then we need to declare the area cylinder data type because we didn't declare the area cylinder data type yet. Okay, so we declare as double area cylinder. Okay, double this one, and then pi is 3.42, and then we remain the formula here, and then what we need to do next is to tell the computer what is the return data type to the main function. So we need to return the area of cylinder to the main function. So we just put here return, and in bracket what is the parameter that we are going to give back to the main function. Okay, right, so so this is the body of function. Okay, I repeat, this is our newly additional function where I name the function as calculate. Okay, so this is the return data type. Okay, since I return the area of cylinder and the data type of area of cylinder is double, so I put it double here. Okay, alright, so this is the parameter that that receive from this function receive from the main function. So since the height and the radius is or are in double data type, so I need to declare here double H and double R. So in this example, calculate function receive two parameters from the main function. Okay, so I remove just now I remove the assignment of pi equal to 3.142 from the main function to the calculate function, because we are going to use this pi or this value in the calculate function, not in main function anymore. So I remove the declaration to here, or the assignment to here. Okay, the calculate function, and then this is the calculation. This is the formula to calculate the area of cylinder, and after I calculate the area of cylinder, then I return. Okay, I ask the computer to return the value of area cylinder to the main function. Okay, since this one is in double, so here is double. Okay, right. So I already explained about the function definition. Okay. And we already created the calculate function. So now in the main function, we need to call the function that we already created just now. So how to call the function? We can refer to the slide on page 62. Okay, so this is the general syntax to call the function. Okay, maybe you can create one variable, and then this is the function name. The function name must be the same, exactly 100% the same as what the name as the function that you have created just now. Okay, and this is the list of parameter, where it is also known as actual parameter, to pass the value. Okay. Okay, in this example, maybe I can create one variable. For example, I create cylinder. Okay, equal to this is the function name, calculate. And what is the parameter that we want to pass? Okay, so since we are not declared yet the data type of cylinder, so we need to declare this newly created variable that we created just now. Okay, so cylinder, since area of cylinder, we are not using this variable anymore in main function, so we can remove this variable, and we can replace with cylinder. Okay, cylinder, and then we call the function name calculate here, the same as the name of additional function here. Okay, and this is the formal parameter. Sorry, this is the actual parameter. This one is formal parameter. Okay, so this one, this line, we call it as function call. Okay, so every time computer meet the name of the additional function, the computer will go to the calling function, to the function definition here. Okay, so since this one is calculate, so the computer will go to the calculate function and bring together the parameter. This one is actual parameter. Okay, this one is formal parameter or arguments. Okay, so computer will bring together the parameters of, or the value of height and radius to the calculate function, and in calculate function, the function receive the value of or the value of height and radius from the main function. So that's why here is H and R. But we can put, or we can name the variable with any name that we want, but in order to not make you confused, I just remain the same variable here. Okay, HR. But you can actually use any different name. For example, high, or this one is red. depends, okay, but I prefer to use the same variable here, okay, in order to explain the the modular programming here. Okay, so we finish declaring the function definition or creating the function definition, and then we finish creating the function call, where in this part we will call the function, okay, and this is the function. We miss one more element in function, okay, like what I mentioned earlier. In function we have three elements. We have three elements here. Alright, we have three elements. I already explained the function about the function definition and the function call, but how about function prototype? Function prototype means you have to tell the computer that you have an additional function here. Okay, so in order to create the function definition, it is very easy. You just copy the function definition here, okay, the first line of function definition, and you put it above main function, okay, and then put the semicolon. So this is the function prototype. So you have two ways to declare the function prototype. The first one is you just you simply copy and paste the first line of function definition like this. The second way is this one is you just copy the formal parameters here, okay, the data type and the name of the variables, but we also can declare the function prototype without telling the variable name, okay, make it general like this, okay. So we have two ways. Either we want to declare the same as what we declared in function definition, or we try to or the second way is we make it more general by putting by putting the data type only, okay, double, okay. So these are the three elements that is very important in function programming or modular programming. The first one is function prototype, where you tell the computer that you have an additional function in your program, so that when computer see this function prototype, the computer knows that in this main function you also have an additional function where the function name is calculate, the return data type is double, and the formal parameter data type is double and double. Okay, so we already creating the first additional function, which is to calculate the area of cylinder. Okay, next we are going to create the second additional function, which is to display the value of cylinder that we already calculated in the calculate function. Okay, we return to the here. Okay, for execution, the computer will always execute the main function first. Okay, like in this example, the computer will execute the main function. The computer will ask the user to key in the height and radius, and since there is a calculate a function call for calculate, then the computer will call the calculate and bring together the parameters of h and r here to the calculate function. Okay, this is the calculate function, and then we calculate the area of cylinder in a calculate function here, and then we return the value of area of cylinder to the main function. So the value of area of cylinder here is saved in this variable. Since this is the variable that we create to call the function of calculate function, then here is we will save the area of cylinder in this variable. Okay, next, what's next? Okay, since the computer is already returned to the main function, okay, after we calculate, and then we want to display the value of area of cylinder, so we want to create another function to display the area of cylinder. So since the second function is only to display the value and the value of areas, cylinder area, so we no need to create another variable. But if you want to create another variable, it's okay, it's up to you. But here I don't want to create another new variable. I just call the function name as display. Okay, and then I bring the parameters. What parameters that I want to bring to the display? The parameter is cylinder. Okay, since the area of cylinder is saved in this variable, so we need to bring this variable to the function of cylinder here. Okay, so that the value of area cylinder here can be transferred to the display function. Okay, so now I already create the function call for display. Function call, this one is function call. Okay, the actual parameter is cylinder. Just okay, and then I create the new additional function. Okay, the name, of course, we need to name the same as what the name that we call the function. Okay, this the function name here is display, and then what parameter that this function receive from the main function. Okay, this one I put it double because cylinder we declared as double here, so here we need to declare double as well. Okay, so double. So what is the variable name or the parameter name? We can put it cylinder. Okay, or we can create any new name. Okay, so in this case I want to create the new name, which is CY. Okay, and then what is the return type? Since it is only a display function, so no value will be returned to the main function. Okay, alright, so this one is the function definition for display function. Okay, this one is the second additional function, so this one is function definition. Alright, so I need to open and close the body of function. Okay, so now what I need to do is I need to put the return here. Okay, semicolon. Okay, return means in every function you have to put return. Okay, either the function is return the value to the main function or no return value. So you need to put return because return, when computer see return, computer will go back to the main function and do or execute the next instruction in main function. Okay, so since I repeat again, since the display function here didn't return any value, not like calculate function. In calculate function we return the value of area cylinder, but in display function we didn't return any value, we just display the cylinder area. But here maybe we can put as CY, CY, because we received the variable of CY, so we need to call the CY. Okay, this the CY. Okay, so this is the return without any bracket. Okay, I just put it return. Why? Because it didn't return any value to the main function. So that's why the return data type here is void. Void means you didn't return any data, any value to the main function. Okay, so when a computer see the instruction of return, then the computer will go back to the main function. Okay, and I think this is okay, I think the programming is complete already. Okay, and then we can try to run. Okay, and try to see either there is a error or not. Okay, see, the error is display was not declared in this scope. Okay, I did the function call, I did the function definition here, but I did not declare the function above the main function. Okay, so I can, as I said, I can copy this the first line of function definition and declare to the and I put above main function. So this one is function definition for display function. Okay, function prototype, not function definition, function prototype. Okay, for display function. Okay, so I tried. So now our program consists of one main function, one calculate function, and one display function. Okay, so I try to run. Okay, error, pi was not declared in this scope. Okay, so you go to this one. Since we didn't declare the data type of pi, so we just declare here. Okay, and then now we can enter the value of high. Okay, for example, I give it as 2.1, and then the radius is 2.0, and then the computer will calculate the value of cylinder, which is 26.39. Okay, and then display the cylinder area here. Okay, like this. Okay, so as I mentioned, the first function that will be executed by computer is the main function. Okay, this is the main function. The computer asks user to enter the height, the value of height, and the value of radius, and then go to the line 17. So since 17, we have in line 17 we have function call, which is calculate, and this is the parameter, actual parameter. So computer will go to the calculate function and bring together the parameter of h and r to the calculate function. Okay, this is the function or additional function for calculate function, and then computer will execute the instruction inside calculate function. Okay, the computer will calculate the area of cylinder here and then return the value of cylinder to the main function. Okay, so the value of area of cylinder will be saved here, will be saved in cylinder variable. Okay, and then computer will execute the next line, which is in line 18, display. So since in line 18 there is another function call, which is display function, computer will go to the display function and bring the value of cylinder that have been saved in cylinder variable here. Okay, so computer will go to display function, and this one a computer will copy or will copy the value of cylinder from the main function to the display function. Okay, and then the computer will execute the instruction inside the display function here. Okay, so since in display function it consists of only one instruction, which is C out, then the computer will display the cylinder area is, and the computer will call the value of CY here. Okay, and then return. Return means return to the main function, and the data type is void because we didn't bring any or we didn't return any value to the main function. Okay, so computer will go back to the main function and do the next or execute the next line, which is line 20. So since in line 20 the instruction is return 0, so a computer know that this is the last line of the program. Okay, alright, so this is example for method number 2. Okay, so now we already created the modular programming, which consists of one main function and two additional function, which are calculate function and display function, where calculate function execute a specific task, which is calculate the area of cylinder, and display function execute a specific task, which is display the cylinder area. Okay, so I already covered the three elements, the three important elements in function. Okay, where the first one is function prototype. So the general syntax of function prototype, you can refer to slide page 56. Okay, this is the general syntax of function prototype. Okay, on page 56, and then I already covered on how to do the function call, where you can refer the general syntax for function call on page 62 of your slide. Okay, this one is page 62. This is the general syntax for function call. And then we also covered on how to create the function definition, where we can refer the syntax, the general syntax to do the function definition on page 42 of your slide. Okay, 42. Okay, this one is the general syntax. Okay, so in terms of method, we already covered the first method and the second method. This one is example 1A and this one is example 1B. Okay, now we move to the next method, which is create the function in different file and call the function from the main file. Okay. Okay, but before we move to method number 3, I think it is good if we can go through the categories of function first. Okay, maybe you can refer to page 26 in our slide. Okay, 26. Okay, for user defined, so for categories of function, we have standard library function, whereby standard library function is already provided from the manufacturer in C++ package. Okay, for example, we have include IO stream, include maths, maths operation, or include IO string. Okay, so this one is the example of standard library function, where we the instruction is already provided in one file, and manufacturer already provide that instruction in one file, and we just call the file, the standard library file, in order to use that. Okay, in our program, standard library function. Okay, this one is, we call it as standard library function. Okay, I repeat, standard library function is the function that already provided by manufacturer, where the manufacturer put this instruction in one file. Okay, and in order to use that instruction or that program, we just call the standard library function. Okay, this one is preprocessor directive, so we just call the preprocessor directive and use this standard library function to our program. Okay. Okay, the second categories of function is user-defined function. Okay, user-defined functions mean a function that created by user for specific purpose or task. Okay, in user-defined functions, we have two two categories. Okay, the first one is user-defined function, and the second one is user-defined header file. So what is the difference between these two user-defined function is that for user-defined function, it is located in the same main file. Okay, in example 1b here, the double calculate function, this one, the calculate function and the display function is known as user-defined function. Why? Because this function is located in the same main file. Okay, define function. Okay, the same goes to the display function. Since it is located in the same main file, so we name, or we know, we name this, or we categorize this or both functions as user-defined function. Okay, another category is actually user-defined header function. User-defined header function is we will use in method 3. Okay, we will use user-defined header file in method 3, whereby in this function, the function is located in different file with main file. Okay, I mean the function, the additional functions are located out of the main function. Okay, in another file. Okay, in another file name. Okay, but before we move to method number 3, I forgot to explain you something about function prototype. Okay, let's say if you don't want to declare the function prototype like this, okay, you have another way, okay, to declare or to use the function. Okay, okay, maybe you can remove this function prototype. Okay, if you don't want to declare the function prototype, what you need to do is you have to put the additional function, for example calculate function and display function, above the main function, okay. So if you put the additional function above the main function, so you no need to declare the function prototype anymore. Okay, you no need to declare the function prototype anymore. Because why? Because computer already known that in this program, since you locate the function, calculate function and display function above the main function, so computer knows that beside main function there are additional function, which is calculate function and display function. Okay, but if you put the calculate function and display function above or below the main function, you need to do the function prototype. Okay, because when executing the main function without function prototype, computer don't know either in this function they have or there are additional function or not. So to make the computer knows, you have to put the function prototype. If you put the calculate or display function and display function below the main function, but if you put the calculate function and display function above the main function, you no need to declare the function prototype. Okay, this one no need. Okay, so you have two ways lah on how to do a programming on method 2. Okay, either you want to put the main above or the main below, but of course computer will always execute the main function first. In whatever location, computer will find the main function first. Okay. Alright, now we already covered method 1 and method 2, and then we move to method number 3. Okay, method number 3, we are going to create the function in different files. Mean one file for main function, one file for the first additional function and one file for the second additional function, like this one. Okay, one file for main function, one file for calculate function, and one file for display function. This one is example 1. Okay, example 1. So I name this example or this method as example 1C. Okay, so I will use user define header file, okay, in order to use to apply method number 3. Okay, so this is the pseudocode for example 1C, whereby actually all the pseudocode is the same as example 1B, but the only difference is user defined function here. Okay, for method number 2 we use okay, for method number 2 we use user defined function, where the calculate function and display function are located in the same main file. Okay, but for method number 3 we use user defined header file. Okay, user defined header file, where the calculate function and display function are located in different files from main file. Okay, so to create modular programming for method number 3, by using that method number 3, we need another file beside main function file. Okay, so maybe you can create a new file. Okay, this one is a new file, and you have to name your new file the same as the additional function name. Okay, for example, in example 1, the first additional function name is calculate, so you have to name your file the same, exactly the same as what you already created for the name, the same as the name of additional function. Okay, calculate, make sure it is the same spelling. Okay, and then you already created a file for calculate, and then we create another one file which is for display. Okay, make sure the spelling is all spelling is the same. Okay, and then you have to remove this function. Okay, you just copy, okay, cut from here and put it in different file. Put it in calculate file for calculate function, and then for display function you have to remove from main file and put it in another file and another one file. Okay, which is display file. Okay, so for method 3 you have 3 files like this. The first one is to execute the main function, the second one is to execute the calculate, the calculation of area cylinder, and then the third file is to display the cylinder area. Okay, for method number 2 we need to declare the function prototype. Okay, in order to tell the computer that in this file we have another additional function. But for method number 3, where we locate the calculate instruction and display instruction in the different area, we need to declare the so-called user defined header file. So you can read the explanation about user defined header file in page 33 of on your slide. Okay, this one. Okay, this is the difference between standard library function that I explained just now before this. Okay, previously you have to put a hashtag include, and this one is arrow. The arrow, left hand side arrow and right hand side arrow, and you put the name of standard library file. Okay, this file is actually provided by the manufacturer, where it is already in C++ package, but this one is your user defined header file, meaning that this file is created by user, and the instruction is put in another file beside beside main file. Okay, I repeat, for include for user-defined header file, it means that you put your additional function in another file, not in the same main file, okay, in a different file from main file. Okay, so this is how to create the user-defined header file. Okay, you need to put hashtag, include, and the name of your file in double quotes. So in example 1C here, you can remove the function prototype, and what you need to do now is you have to declare the user defined header file. So since the name of your additional file is calculate, so you have to include here, include, and you have to put double quote, okay, and you have to put the same name as the file name, okay, the additional file name here, calculate. Okay, this one is the first additional file, and the second one, oh, no need to put semicolon. Okay, then you have to include the second file, which is display. Okay, so this one is user defined header file. Header file. Okay, so for this example 1C, we have 3 files. The first one is is the main file, and then calculate file and display file. So in order to execute your program, you need to go to the main file, and you have to run from here, from the main file. Okay, and then okay, you try to enter a cylinder height 2.1. okay, and then try to put radius 2.0, and then when computer see the file name as calculate, because this one we already declared as user defined header file, so when computer see the name of calculate, it will call the calculate file over here. Okay, it will call the file calculate and bring together the parameter of H and R to the calculate file here. Okay, so from calculate file will receive the parameter of H and R from main file and execute the instruction inside here and return the value of area cylinder to the main file. Okay. Okay, the process is the same. It just like the location of instruction is in different files. Okay, so you could enter here, and then it will show in output console. It will show the output console will show the cylinder area, which is to 26.39. Okay, the calculation is inside here, and the display is in display file. Okay, okay, for display, computer will bring the value of cylinder to the display, because there is a function called here display. So computer knows that display is in another file, because we already declared here as user defined header file. So computer will go to the display file and bring the value of cylinder area, and then will execute the instruction inside display function. Okay, the cylinder area is call the value of cylinder area and return to the main function without any value. Okay, so this one is display, and then computer will execute the next instruction, which is return 0, which is the end of the programming. Okay, so this is method number 3. Okay, so in slide you can refer to slide 23 until 25 for method number 3. Okay, this one is in main file, this one is in calculate file, and this one is in display file. Okay, so until now we already covered the method 1, method 2 and method 3 of computer programming, where for method 1 all programming instructions are put in one main function. Method number 2 is we are creating a function or a modular programming, where we create another additional function in the same main file. Okay, and for method 3 we create additional function and we put the instruction in different files from the main file, but we execute the program from the main file. Okay, and then if you look at this point, I already covered the first, the second, the third, and the fourth points. Okay, so for what I have explained for method 1, method 2 and method 3 is what I have explained in method 2 and method 3 is about an example of pass the parameters by value. Okay, whereby we pass the parameter of h and r to the calculate file by using the value. Okay, the value. Okay, for example, I put 2.1. I put the value of height is 2.1 and the value of cylinder is 2.2. So I pass the value from main function to the either user defined function or by using method 2 or method 3. It is the same. Okay, I pass the value by I pass the parameters by value. Okay, by value. So this one is value, this one is the value. Okay, so based on this value, the computer will execute the or calculate the formula of area of cylinder, and then I pass the value of cylinder to the display function to display the value of cylinder. Okay, but for pass by reference, I think I want to give an example in the next video. Okay, so in this video, which is in part 1, I already covered pass by value. Okay, pass by value in method 1 by using method 2 and by using method 3. Okay, for pass by reference, you have to watch the next video. Okay, so by that I end the video for part 1 here of chapter 4, which is on functions. For pass by value, for pass by reference, you can watch in the next video. So thank you very much.